Welcome back to day 5 of our embedded system series. In our previous session, we learned about microcontrollers, memory architecture, RAM, flash memory, and about the registers. We understood that RAM is used in storing data, flash memory stores our program, and the CPU processes the data stored inside memory. But today, we are going to focus on a very important question. What exactly is the data that we store inside the memory? Can memory store numbers, or can it store letters, or it can also store the decimal values? And how does the compiler know the difference between all these? To answer these questions, we need to understand a concept called data type. Before we begin, let's see what we'll cover in today's session. We will understand what a data type is, why data types are needed, the different data types available in C language, how much memory they occupy, the difference between signed and unsigned values, and also finally the fixed width data types that are commonly used in embedded system. By the end of this session, you will know how to choose the correct data type instead of blindly using int for everything. Let's start with a simple example. Suppose I want to store the value 25. Suppose I want to store the letter A, or suppose I want to store the value 36.5. All these values are different. One is a whole number, one is a character, and one is a decimal number. So, naturally, the compiler needs a way to identify what kind of information we are storing. That's exactly why data types exist. Think about supermarket. Rice is stored in one section. Milk is stored in a refrigerator. Vegetables are stored somewhere else. Different items require different storage methods. Similarly, computers handle different kinds of information. The value 10 is different from the character A. A character A is different from the value 3.14. Since they are different, the compiler must know what type of data type it is dealing with. That's where data type comes into the picture. To get today's PPT and the free resources, please join to our Telegram group. The link will be given in the description box. A data type, so let's get back. A data type is in a simple way of telling the compiler what kind of data we want to store. It answers three important questions. What type of information is being stored? How much memory should we allocate? What operations can be performed on that data? You can think of a data type as a label attached to a memory location. Without that label, the compiler has no idea how to interpret the data stored inside the memory. Now, here is something very important. Memory does not understand numbers. Memory does not understand letters. It does not understand the decimal values also. Everything inside a computer is unlimitedly stored as 0 and ones. Whether it is a number 100, a character A, or a value of 3.14. Everything is stored as a binary data. The data type simply tells the compiler how those bits should be interpreted. Okay, so uh, C provides several built-in data types. The four most commonly used ones are char, int, float, and double. Each one is designed for a specific purpose. Let's understand them one by one. So let's start with char. The word char stands for character. It is used to store a single character such as A, B, C, or any symbol. For example, char grade equals to A. A char typically occupies 1 byte of memory. Since 1 byte contains 8 bits, it is enough to store a single character. Whenever you are dealing with letters or symbols, char is the right choice. The next data type is int, which stands for integer. Integers are used to store whole numbers. For example, int age equals 25. Values like sensor readings, counters, distance, or the quantities are commonly stored using integers. On most STM32 microcontrollers, an int occupies 4 bytes of memory. Since whole numbers are very common in programming, int is one of the most frequently used data type. So, to get today's PPT and the free resources, please go and join our Telegram group. The link will be given in the description box. Now, suppose we want to store a decimal value. For example, 36.5 degrees of Celsius or 3.14 voltage or 12.75 centimeters. An integer cannot store decimal values. That's where float becomes useful. A float allows us to store numbers that contain decimal points. This data type is widely used in sensors application, measurements, and also in calculations. A double is very similar to float. The difference is that it provides higher precision. In simple words, it can store more digits after the decimal point. For scientific calculations, it can be very useful. However, a double consumes more memory and requires more processing power. Since embedded system has less resources, engineers use double only when extra precision is actually required. Okay, so now let's compare these size. Okay, a character usually occupies 1 byte. Okay, an integer occupies 4 bytes. A float occupies 4 bytes, and double occupies 8 bytes. It's the double of float. Okay, so notice that as precision increases, memory consumption also increases. This is why selection of correct data type is very important in embedded system. You must wonder why we care so much about a few bytes. On a laptop with several gigabytes of RAM, wasting a few bytes doesn't matter. But in embedded system, it's different. Many controllers, as we discussed earlier, have only a few kilobytes of RAM. When memory is limited, every byte becomes valuable. Choosing the correct data type helps us use more efficiently and build better embedded applications. To get today's PPT and the free resources, please go and join to our Telegram group. The link will be given in the description box. Let's move to another important concept. Sometimes values can become negative. For example, temperature can be minus 10 degrees also. Profit can become loss. Altitude can become below sea level. To store both positive and negative values, we use signed data types. A signed data type or a variable reserves represent one byte to represent the sign of a number. Now, think about the LED state. Can it be negative? No. Can ADC reading be negative? No, again. In such situations, using a signed variable is unnecessary. Okay, so we can use an unsigned data type. Unsigned variables store only positive values, which allows them to represent larger positive numbers. Now we come to something extremely important for embedded system. Professional embedded engineers rarely use plain int. Instead, they prefer fixed width data types such as uint 8 underscore t, uint 16 underscore t, uint 32 underscore t instead of using int and 8 underscore t, int 16 underscore t, or int 32 underscore t. The reason is simple. These data types have guaranteed size. Okay, and uint 8 underscore t always means only 8 bit. Similarly, the uint 32 underscore t always means only 32 bits. So these makes the code more reliable and portable across different systems. Let's see at a practical example. Okay, suppose we want to store the state of an LED. The value can be only either 0 or 1. Using 4 bytes would be unnecessary. Uint 8 underscore t is enough to store a 0 or 1 output. Okay. Similarly, in an ADC reading may require 16 bytes. So we can use uint 16 underscore t. The timer counter may require 32 bytes. So uint we will be using uint 32 underscore t. Becomes a better choice according to me. So good embedded programmers always choose the data type based on the actual requirement. Okay, so let's quickly summarize today's session. Today we learned what the data types are and why they are very important. We understood that memory only stores bits and that data type gives meaningful meaning to to the bits which we use. We explored about char, int, float, and double. We also discussed memory consumptions and assigned integer or an unsigned values and the importance of fixed width data types in embedded system. So in our next session we will be learning about operators in C language. We'll see how to perform calculations, comparisons, and other logic operations. Okay, so to get today's PPT and the free resources, please go and join to our Telegram group. The link will be given in the description. And